Hi, we're the EPICS group working with Bridge2Africa at Arizona State University. My name is Rajat and I'm the team lead. I'm a sophomore in electrical engineering and the lead hardware developer. Adrian Inocencio is a computer systems engineer and one of the lead software developers. Nadi Jafar, our finance chair, is a computer systems engineer and also one of the lead software developers. Finally, we have Abby Jansen, who is a chemical engineering major and our lead research chair.
So I'll start by giving a little bit of background about the origins of our project. To start off, we're all students at Arizona State University. At ASU, we are all part of the EPICS program, or Engineering Projects in Community Service. This is a program where student teams work together, partnered with nonprofits, to help solve their engineering challenges by designing, building, and testing solutions. Our specific nonprofit we were paired with is Bridge2Africa, a South African nonprofit that focuses on enhancing education and technology in various communities. They focus on bringing people together in diverse learning experiences. Bridge2Africa specifically paired us with the Sibonile School for the Visually Impaired. This is a public school in South Africa that helps to teach students who are blind or otherwise visually impaired. Currently, the school teaches around 200 students and helps to integrate them into the communities through education. Specifically in South Africa, there are a lot of problems with the visually impaired population. There are currently 419,000 people living in South Africa who are visually impaired to some extent, and of these people, 97% of them are unemployed. This is due to the shortcomings in their education because of their different abilities and the lack of education that there is surrounding that.
So to give you an overview of the problem that our team is trying to tackle, we've decided to focus on the internet. That's because in today's age, the internet is used as an educational tool in classrooms in order to facilitate activities, to exchange information, to communicate with teachers and peers, as well as a copious amount of other things. So the reason why the internet has become a problem with visually impaired students is because the internet tends to be very vision-based, in the sense that there's a cursor for browsers. So in order to navigate through web pages, you need to know where the cursor is. There's usually images, there's links and stuff that you need to know its location on the screen in order to interact with it. The reason why we need to make this technology is because the assistive technologies that are currently in place have a lot of shortcomings, and so they're not engaging with visually impaired students. Some of these shortcomings include the fact that a lot of them are audio based, so that leads to passive learning because the students are not engaged, they're just listening, and so they're not retaining a lot of the information. This leads to a lower educational level and then eventually a higher unemployment rate, as Abby mentioned. Another problem is that they're extremely expensive and they're not intuitive. So our goal is to help students in K through 12 learning, and these students are not going to understand like the shortcuts and the intricacies of these tools, which is why we want to make something that is very intuitive. So in order to introduce our solution, we have a functional decomposition. So this is what our product would look like. It would be a keyboard that would be able to connect to any laptop or personal computer device via like just any USB wire. And the function of this computer is that these little cells right here would emulate like a Braille character, and they can go up and down in order to refresh and convey like long text of information line by line. So on the computer side of it, we would have a browser open, any browser, and our software would be able to read the textual information that the browser is displaying and then translate it into Braille, and then this information would get sent to the keyboard. So they would be able to read this information on this keyboard. So to go a little bit more in depth on the software side of things, the user would have a web page open, and our screen reader would be connected as an application to this web page. It would traverse through the web page, and it would decide what information is textually important for the user to identify whether that web page is something that they want to do or want to read and go through. So for example, if they're on like a Google a page of articles and links, the screen reader would go through link by link and display that title in Braille in order for the user to identify like, okay, this is the link that I want to go through. So the screen reader would link to our application, and then our application would translate the text to Braille and then send it to the hardware side, the Braille board.
So displayed here is the two components of our hardware. So on the right side, you'll see the more built full Braille keyboard with 20 characters in completion. And on the left side, you see the individual breakdown of individual characters that are displayed for Braille. So the way it works essentially is you have DC motors or another type of motor, and you have like a threaded component on top of the axle, similar to like a screw. And within that there's a bolt, and the bolt can't rotate left or right because of this housing on the outside. So when the motor rotates the thread, all it does is force the bolt to go up or down. So when the bolt goes up, when it's rotated, it makes contact with this little pin right here, and essentially this clicks into place. So when it clicks into place, it displays the pin, which can be felt by our user, and then when you rotate it again, you can click it out of place, similar to how a clicky pen or how a spring-loaded pen works. On the right side, you see the full 20-character built display, and as you can tell, along the top there are several buttons, and that's input for the user. So there are things that they can control, like the speed at which the Braille is being refreshed. There is the speed at which the audio is being told, and then there's the ability to switch between audio, switch to Braille, or a combination of both. In terms of the progress we've made so far, we have the hardware prototype. What you see here is a 6 solenoid motor configuration, and essentially this was a proof of concept that our Arduino could communicate with our software aspect, which Adrian will discuss later. So what we have are these blue solenoid motors. Essentially they're push-pull motors where if a voltage is applied across of it, then the pin gets pulled in, as you can see among the bottom ones, and when there isn't voltage, it gets pushed out, as you can see among the top ones. So as you can tell in this one, these 3 are down, these 3 are up, displaying a certain character, and this was just proof that we could actually display, or we were actually able to communicate with a hardware component that our software works, essentially.
Just like with our hardware, we're trying to create an MVP for our software. Our overall goal for our software is that we're trying to create an easy-to-use screen reader to use in conjunction with our Braille board, and also a tool to help children read Braille. The progress that we made so far is that we were able to parse information from the internet and then transfer that information into Braille. Some of our next big steps is that we want to incorporate some audio feedback, also some easy-to-use shortcuts, and basically just features to help us get closer to our overall goal of making an industrial or easy-to-use industrial screen reader. So for our business model, we're going to go over our cost model as well as our marketing strategy. So this is our particular cost model. For our screen reader software, it's going to be open source. It's going to take $0 to actually develop the software itself, since we're creating everything from scratch. Our hardware itself, the refreshable Braille display, is going to cost overall $110. The reason why, because it incorporates the following components. Our motors, which are just DC standard smaller motors. 3D printed internal components, which will be using heavy duty plastic filament to print these components. Small microcontrollers and just basic circuitry, and as well as just miscellaneous stuff such as wiring, screws, springs, etc. So how are we going to appeal and implement our project? Is that we're first going to create a website. Our website is going to incorporate all the different information about our project, as well as just share our journey as we go along with this project. We're also going to start a Kickstarter, which is a public funding platform. With this, we'll allow to get public attention with our project, as well as get some sort of medium to capture some initial capital to fund our project. We also apply and create or publish academic papers to help increase our integrity as a team and also validate our project itself. We're also going to apply for grants within our institution, such as the Changemaker Challenge and EPICS itself, but also out of our institutions, such as the AFB grants, which are American for the Blind grants. These grants will definitely help us fund our project and really get a great sum of capital to fund our project.
So here we have a product roadmap so that we can kind of see where we're going to be in the coming months and the coming years. So for our goals and timelines, we have a hope to begin production of our concept Braille boards by this February, which is next month. We want to have a working concept of our Braille board with the screen reader by May of 2019, which is later this year. And our biggest goal is to have a refined, marketable Braille board by early 2020. So that's a estimate and projection of where we're going to be within the next year.
Thank you for your interest in our project. We hope that you enjoyed it.
And we want to personally thank Justice Kumbuchuma, who has been supportive of us and has encouraged us throughout this journey.
We're so excited about the prospects ahead, and we hope that you can stay up to date with our project.
And if any more questions or want to contact us, just email us below.